Hi, I'm Meta Spencer. Boy, do I have a treat for you today. We get to have a good conversation with one of our generation's greatest journalists and a really good guy, Gwen Dyer. Imagine that. He's got the greatest nose for interesting topics and important topics. And he has certainly found a winner now because he's just publishing a new book about geoengineering. And that has to be the most significant thing that people these days should be thinking about and considering, because we got a world to save and we're not doing a very good job of it so far. So he's got some new tips on how we can take care of ourselves and leave this planet in better shape for the next generation. Hi, Gwen. How are you today?
Hi, Meta. I'm very well, thank you.
Good. Okay, let's get right down to work because I want to hear about your book. I've got it on order and it's going to be coming in within a week, I think, onto my Kindle. Tell me first of all the title, and then let's get down to talking about geoengineering.
Okay, well, it's called Intervention Earth. Does sound like a 1950s science fiction movie, but on the other hand, it does describe the subject fairly accurately. And it's out in Canada now. It's coming out in England next month, Australia, New Zealand. So it's staggered publication, mainly so I can be in the country it's being published in when it comes out. It's basically a survey of the field, not just of the geoengineering field, but of the state of play in terms of what are we doing to deal with global warming and what are the timelines. I mean, lots of good ideas out there, but when are they going to be able to scale up and start having a real impact on the planet? And because essentially what we've got here is a situation globally, but it's mostly in the developed countries that the work's being done. About 15 or 20 years ago, we realized, or at least a great many people realized, we do have a problem here. And a great many scientists and engineers and inventors and all sorts of other folk started thinking about ways of dealing with the warming problem. And as you would expect, it took a while. I'm not saying that was a good idea, wait 20 years. I was saying it's human beings, guys. What did you expect?
Okay.
And but it is happening now. I mean, every month there's something coming out. Well, what if we did this, that we could cut the emissions there and all the rest of it, all good ideas. But because of that 20-year delay, while various people found the money to do some research and then some modeling and then some actual sort of prototypes of this or that or the other thing. I mean, for example, we've been discussing direct air capture for 20 years. The very first enterprise at scale to try to do that is only now beginning to be built in Texas and in Louisiana. 20 years.
Yeah.
Part of it is politics. Think of who is in power in the United States for most of those 20 years.
Half of the problem is the timing. The other half is what really will work or what is affordable in terms of the amount of energy it will take to do it. And
I agree.
Direct air capture is one of the question marks. You got to convince me that you're not going to use up more energy than it's worth.
You're only going to convince people that it is or is not worth doing by trying to do it. But the problem is that all of these good ideas have to be rolled out at scale. I mean, obviously try it in a smaller scale first, but in the end, to make an impact, they have to go to scale. And the question is always, how long will that take? I mean, if you look, for example, at the most successful way of getting out of fossil fuels, which is actually solar capture. Now solar panels have scaled up. They're everywhere. They're taking a significant bite out of the problem. But that took 20 years. I mean, the first solar panels were sort of put out to test about 20 years ago. And it took that long. So what you want to do is to take that kind of, okay, how long will this take? When can we see real effects from it? To about every proposed technique, every available and every imagined technique. And unfortunately, the ones that are starting to come out on the table now are not going to be at scale in 5 years' time. They might be at scale in 10 or 15 years' time. Apply that against the fact that you are going to be certainly past 1.5 by 2030. Frankly, we're past it right now, but we may drop down a bit after the El Nino, passes.
Right. Mm-hmm.
Though we won't drop back down to where we were before. I'd be very surprised if we were below 1.4 a year from now. Which means that there isn't much time for these projects to go to scale and make a difference and stop the inexorable move towards 2+2. So you have, and you have to make that argument, and that's what I've tried to do in the book, make that argument to say, yeah, all these good ideas, look at them, put your shoulder behind them, do work on developing them as fast as you can, figure out which ones are most cost effective, all that stuff. But you just look at this and you can see that's not going to solve our problems in 2030 or 2035. So you do therefore have to look at geoengineering. I mean, you don't know the details yet, but you're going to need that. If you don't do that, then you are going to bust through all the barriers.
I thought you were saying, which I think is the case, that even the geoengineering ones aren't going to be ready that quick. Last year, I did a series of shows with the Canadian Pugwash Group, and I picked 4 of the different modes of solving global warming that I thought could be started within 5 years. I'm not sure they're all would be equally ready to go. So I think really the question is which of the geoengineering ones can we get going quickly?
Very good question. No, obviously that's the other question you have to ask. But, you have to take your audience to the point in the argument where they agree that we need to consider geoengineering, then you go through the process of, okay, what's cost effective, what's available quickly, what are the risks, all that stuff. But they're not even going to listen to that until you persuaded them they have to worry about geoengineering working, because nothing else is going to,
Absolutely.
So you do have to work your way through the weeds and talk about why, in fact, solar power is brilliant, and what it has succeeded in doing over the past 10 years is prevent the proportion of fossil fuel power in the mix globally from getting worse. It hasn't actually cut into that 80% share of power coming from fossil sources. What it's done is it's kept up. The non-fossil has managed to keep up with the rate of growth in the fossil, and kept us at 20% non-fossil fuel. That's not enough, obviously. You got to get a lot better than that, but it ain't going to happen overnight. I'm talking about the share of fossil fuel, which has been 80%. Since I was a boy, practically.
Right.
Well, actually, it was worse when I was when I was a boy, because there wasn't anything else. But certainly for the last 15 years, what's happened is that fossil fuels have grown, of course, and non-fossil power has also grown, and it is managing to grow at the same rate as the economies expand, and therefore, at least, we're not losing ground. But that's not enough. So, but
when I talked to Sean Fitzgerald a while back, I said something about it's the the use of fossil fuel energy is still increasing and not even going in absolute numbers, not even going down. And he said, yes, but the rate at which it's increasing is decreasing. So it's plateauing somehow.
I would not mock him for that remark because it's very close to true.
Yeah, I
And,
think so.
but the point is, we do have the technologies, we don't have quite the political will yet, but I think it might be true to say that within a year or two, we might see the share of fossil power in the mix drop to 80% or even 79%.
Okay.
We are making progress slowly. That's the point. We are making progress, but it's not fast, and you are going to hit levels of carbon dioxide in the atmosphere and methane, which will drive you over 2 degrees sometime in the 2030s. It could be the early 2030s. There's a great deal of false optimism out there because people don't want to talk about what happens and what you do about it if we actually do go to 2. But I think the odds are even that we will go to 2 in the 2030s unless we get some geoengineering going. And therefore, but you have to make that argument, and then halfway through the book, you trail. At the beginning, you're going to talk about geoengineering, but to get their attention, you've got to tell them that other things aren't going to work. So you do that, and then you start talking about the geoengineering and which of those techniques will be most effective, most rapidly expanded, all that good stuff.
Mhm.
It's an argument, particularly for people who haven't taken it aboard and who have been told repeatedly that this is dangerous.
Yeah, I know. It's crazy. Yeah. Well, it could be, but that's the
It
problem. We're
could be.
not
Yeah.
100% sure, but
No, but I mean, I was talking to David Keith the other day, and who I think most people watching this will know.
yeah.
And he said, listen, the research is done. We could do it tomorrow. Talking about solar
Mhm.
SAI,
Mhm.
stratospheric aerosol
Aerosol
injection. Yeah.
injection, yeah.
Yeah. He said, we could do it tomorrow. And I actually think he's true because, as everybody says, volcanoes have tested this for us.
You're right. Yeah.
But
I mean, but by the way, Harvard has just killed their project on SAI.
well, that's why he
It,
moved to University of Chicago, I think.
oh,
But he had already made the jump to Chicago about
mhm.
6 months ago, and probably
Yeah.
talked about it 2 years ago. You know, um, and University of Chicago is giving him far more resources than Harvard ever did. So this is not necessarily a bad thing. But the work is still being done by under 100 people. That's the fact of the
You
matter.
mean SAI work in general? The number of people working on
The
SAI?
number of people who are actively was yes, I would say the number of people who are working full time on that would not number more than 100.
Well, I
I,
think,
I
frankly, there are a lot more promising things. Frankly, I would say marine cloud brightening has a lot more promise. I would say iron salt aerosol has a lot more promise. I would say cirrus cloud thinning even has a lot more promise, and maybe ocean iron fertilization. Although,
but yeah, no, those are the ones we should be looking at. But just to get people to look at them, you've got to persuade them that they don't have other easier options.
yeah, right,
Easier in the sense of less frightening and easier politically and so on.
yeah, okay.
So there we have the geoengineering options, and none of them have been tested outdoors. So we are virgins discussing sex. It's um,
Um,
but I agree with you that marine cloud brightening is the most promising and the least threatening. And both of these things are
it's
important.
not
You can
ready
turn it
though.
off right away if there's a problem.
It's not ready.
I know it's not ready. There is nothing we're going to discuss this morning that's ready.
Well, I think there's some things like the iron salt aerosol. I think they could do that next year.
That's next year. Yeah. No, I know some of it's can come online faster than other bits, but ready at scale, I think you're looking at 5 years for anything.
Okay.
I mean, but that's a political calculation, not a technological calculation. The
Yeah, well, from
argument,
that standpoint, sure, because it's going to take that long to get people on board. That's why the challenge is to work on people as much as
yeah,
it is, and on public opinion as much as it is to work on the technology. I mean, you got to do both.
I couldn't agree more. Yeah, that's what we're doing, isn't it?
Yeah,
Right here, right now.
you and me, we're a team.
Yeah.
Okay.
So how do you go about? I mean, there's strategies for getting people on board in terms of persuasion, in terms of publicity, in terms of getting it into the political debate as well as the philosophical debate and the technological debate. Is time consuming. I mean, for example, here in Canada, they're still having a huge argument about carbon tax.
Yeah, I know. Mm-hmm.
You know, I mean,
And I think it's going the wrong way. I think they're going to abolish a lot of it. I don't know.
well, I don't know if they will or they won't, but it is having an impact, and it would be a loss. And since Canada cannot apparently deal with its huge carbon guilt over Alberta oil, that at least was compensating in part. I mean, because we really are the skunk at the dinner party.
Yeah.
But beyond just the here and now, over the next 5 years, yes, you have to find a way of persuading the public. Now, nature will help you because it's going to get worse.
Mm-hmm.
And I don't know if this year is going to be the record bad year that people were predicting after the disaster of last year. And particularly Jim Hansen saying, watch out, this is going to be the year that we bust through 1.5 really big time. The jury's still out on that. It's only March as we're talking. And
but February was the hottest February on record in the world.
January was the hottest January. December was the hottest. We have 9 months in a row that were the hottest month ever. So that has got us to, we're past 1.5. Mm-hmm. On a monthly basis, we've got 9 months now past 1.5. The technical definition is the average of the 20 years out, sort of 10 years ahead and 10 years behind, is if we're past 1.5 on that 20-year average, then we're past 1.5. Sorry, guys, that's the wrong way of looking at it.
Right, exactly.
Because you're not working out an average that's stable. You're talking about a moving target. And when it goes through 1.5, it doesn't go back to averaging out. It just goes up.
Absolutely.
But there's a debate now underway in the scientific world about whether that is the right way of defining 1.5. Only a little, 5 years late. Why not? And but we are in deep trouble, and we will probably know a lot more about how deep the trouble is and how fast the warming is coming, how much faster than we expected. By the end of this year, because really, if we have another year like last year, we have much to worry about. If we have a worse year than last year, we are in deep, deep trouble. We are in feedback heaven. We don't even know why yet. 1 degree higher ocean surface temperature by average than any of the models explain right now.
Right. Mm-hmm.
And that could be the first big surprise of all the surprises. That is the whole thing that drives. We got to get some way of countering the feedbacks, the tipping points that produce the feedbacks that go runaway. All of our calculations are on linear growth of warming.
Yeah.
But we know damn well that there will be nonlinear jumps in warming if we cross certain thresholds. This may be the first such threshold.
Mhm.
Not one of the ones that we were predicting. A sudden 1 degree anomaly in sea surface temperature was not on the list of 20 bad things that might happen that would carry us towards sudden jumps in warming. But it could turn out to be one of them. It could turn out to be a proper feedback caused by some tipping point we didn't know was there that is driving sea surface temperature up. So you've got to be prepared for those things. You know, if it turns out that this year is worse than last year, or even as bad as last year because it was really bad, then just look out the window.
Mhm.
So you're actually, in terms of persuading people to take geoengineering seriously, we do have an ally. It's an unwelcome ally, but allies are often unwelcome. You know.
Well, so also just plain forest fires and floods and things like that. The more, I mean, if people look out the window and see there's a forest fire coming at them and things, those are very persuasive events.
They are, although it's odd how, I mean, you know, if you think about, for example, what's happened in British Columbia over
Mhm.
2 of the past 3 years, or Alberta too, I mean, Fort McMurray and all that stuff.
Mhm.
Look at the way it's being reported. I mean, people are saying global warming occasionally in the course of it, but it is not a drumbeat of this is caused by a problem you're not paying attention to. Fighting fires, digging fire breaks is not the answer. You won't stop it that way. That needs to be emphasized every time it happens. And, you know, somebody's got to do that. Who's going to be it? You know, you, me, who else?
Mhm. Well, not the newspapers, not the networks.
Yeah. So a lot of work to be done.
Indeed. Okay, now you went around to talk to experts and you came up with your own ideas of which geoengineering technologies are promising, which ones are possibly cost effective and realistic in terms of feasibility, and which ones can be done quickly. So I don't know what kind of priority system you've got set up, but I'd be very interested in comparing your notion of what you would bet on to my notions of what, which are always in flux because I change my mind every other day. But
Well, I think we all do because there's a
yeah,
lot of uncertainty.
yeah, that's so
But
unfortunate. Yeah.
yeah, well, that, you know, that is the stage in which human beings live generally. So, you know, no
Mhm.
surprises there. Um, I think that the one that I would be most confident in deploying the day after tomorrow, not that there's any hardware out there to deploy, but, you know, we are closer to being able to deploy and would meet with less opposition if we did deploy. Who's we? I don't know. Um, with marine cloud brightening than almost anything else. I felt that from the start. It is very hard to say that that is a mortal danger. It can't go very wrong because you can turn it off overnight.
That's what I think the persuasive thing to me is how quickly could you change your mind if something really bad happened? And if
That's
you
right.
tell people, look, within a week we could stop the whole thing anyway, I
Yeah.
think people are more willing to say, okay, let's give it a try.
Well, that's right. Now, and that could have a very large effect.
Mhm.
Um, Second is in terms of operating at scale.
Mhm.
I'm afraid, to me, is solar SAI,
Yeah.
injecting
Mhm.
aerosols into the atmosphere. Again, you can't turn it off right away, but you can turn it
Right.
off in,
It'd be a couple of years before the stuff starts settling
well,
to Earth.
frankly, most of it falls out in a year. If it took a couple of years is pushing it. I mean, you're down to very low levels at 12 months. It won't
Right.
all fall out, but it's because this is a statistical operation. But whatever might be causing a problem at the beginning of the period will be halved in a year,
Mm-hmm.
and or more than halved in a year. I cannot imagine, if you consider how the Pinatubo volcano put, best calculation, 17 million tons of sulfur dioxide into the atmosphere.
As you can see, Gwen and I are wearing different clothes. That's because we had to interrupt our visit a few days ago and wait almost a week to resume it. And in the meantime, I guess we changed clothes.
Yeah.
And so we will, but we know what we were talking about. And I want to pursue that a little bit because Gwen was reminding us that SAI can be sort of demonstrated by the effects of Pinatubo, which emitted something like 17 million tons of sulfur. With what effect?
Well, the one effect was that it's sulfur dioxide, actually, it's the
Uh-huh,
gas.
uh-huh.
And it reflected a good deal of incoming sunlight, as sulfur dioxide does, but now it's coming in very large quantities from this volcano in the Philippines. And we had a global cooling, average global temperature down by almost 1 degree Celsius, tapering off over the next 2 years. So, yes, you can cool the climate. No, you don't need a volcano to do it. You could just go buy some sulfur dioxide. It's an industrial gas. First of all, you capture it from all the places that put it out as pollution, but you can also buy it, make it. Um, and, and nobody died. There is no living things to speak of in the stratosphere, which is where it was. There were no grave effects in having 7 million tons of this stuff in the stratosphere for 2 years.
Yeah.
We would never be putting that much up, or at least not for a very long time. If we kept on doing this for half a century, yeah, we would be, but that's not what the idea is to do what they call peak shaving. Don't let the temperature go above a certain area while you frantically get the carbon dioxide out of the air and can stop geoengineering. So, but 17, that's a number way beyond what we would be doing if we began doing SAI.
Mm-hmm.
1 billion would be more like it. Sorry, so am I saying billion or million here?
A million. Mm-hmm.
Million, sorry. 1 million tons, 2 million tons a year would be more like it when you start even smaller than that, but build up over a few years, watching carefully to make sure there are no surprises, but there shouldn't be, because volcanoes do this at a much larger scale very abruptly.
Mm-hmm. Mm-hmm.
So there is your, it's not exactly a get out of jail free card, but when people realize they had a big problem, they also realize that if you needed it, you do have a quick solution. The slow solution, the final solution, the one that works permanently, is getting rid of emissions and not putting any more out. But even then, they realized that was, even then being, let's say, the late 90s, early zeros, they realized that getting rid of all the emissions in a world that is 80% powered by fossil fuel was going to take a while. They had no idea how long that was going to be, because we haven't got rid of any of it yet. But they did understand you needed a fallback. So from the late 90s of the last century, there were a number of people who were investigating the implications of doing what we know volcanoes do, but doing it obviously with aircraft or some other means. There were early open air experiments, not using sulfur dioxide, but sort of the British had a program in the around 28, 29, 2009, 2009, to see what kind of what ways you could boast it into the stratosphere. And there at the time they were trying to do it with a large balloon and a 23-kilometer pipe, which seems to me
Yes,
probably
I
not the best way of
talk
doing it.
about a big, like a drinking straw going into this.
That's right. Yeah, it was called the Spice Program. And I've talked to some of the people who were involved in it. They never intended to do it. They were just, sort of investigating the technology mathematically. And they thought maybe at the end they'd, boost a couple of bathtubs full and spill it over a field in Norfolk in order to demonstrate that they had actually done some real experiment. But it was mostly mathematical studies and that sort of thing. So there was a lot of interest, but what began to happen right away was that some people in the scientific world, and quite a lot of people outside the scientific world, opposed even thinking about it, because at that time the assumption was cutting emissions was going to be easy. So don't distract us from this quick fix we're going to do, switch 80% of the world's energy use over to non-fossil fuels in 10 years or 20 years. And so don't distract us with other things. They're just going to slow the process in the one technique that we know is permanent and works. Problem is that that view that anything that distracts from emissions is negative, is slowing the process, has persisted, although the process never got started. We have never cut emissions. And in the very best days, our emissions that year dropped a bit, but they're always going up because it's cumulative. And we are now, we were at 1990, we were at about 350 parts per million of carbon dioxide in the atmosphere. We are now at 425 parts per million. After 30 years of trying to do it, we have lost that much ground.
Right.
So it's a bit unrealistic, I would say, at this point, to take the position that we must not experiment with ways that keep the temperature from running completely out of control, because any experiments in SAI would distract from the job of getting rid of the carbon dioxide. You could convince me of that if you're getting rid of a lot of the emissions now, and I don't want to slow your process down, but you haven't even got it started in 30 years. So don't tell me we shouldn't look for fallback positions when you are failing. So that's
right. I think of it as more than a fallback position. I think already it's going to be inevitable and necessary, completely essential. Let's get on with it. Let's find what we can do without.
Oh, I do agree with you, but I'm taking a minimalist position here, if you don't mind. But, the bottom line, yes, of course, it's 30 years later. You've used up your thinking about it time. But there we are. So that one occupied most of the space because it's the one that has, in a way, been pre-tested by nature. There are other gases or particles that you could put in the air that would also reflect sunlight in the stratosphere, or even in the troposphere, in the bit down where we breathe, the thicker atmosphere at the bottom. But, the focus is on sulfur dioxide because we know it works and we know it doesn't kill people. And yeah, there has been a bit of an issue with ozone holes possibly not shrinking so fast. I've talked to a lot of people about that. That's one of the arguments you often hear used against it. And the problem is that Um, there, while sulfur dioxide does not actually directly cause ozone, it kind of operates as a catalyst by which CFCs, you know, those things that got banned in the 1990s, it's the CFCs that destroy the ozone, but they destroy it faster if there's a lot of sulfur dioxide in the air over the poles.
I didn't know that. Okay.
That's how it works.
Mm.
You know, we've had a lot of attention on that over a period of about 40 years because we dealt with the ozone hole 40 years ago, and we dealt with it by cutting all of the CFC emissions, although we grandfathered them, so they only really started getting caught about 30, 20, 10 years ago in some cases. But the ozone hole over the Arctic never grew at all, and the ozone hole over the Antarctic began to shrink. And it's still shrinking. The amount of ozone that was destroyed by Mount Pinatubo was not inconsiderable, but I mean, if you sort of scale it down to the kind of sulfur dioxide volumes we might be putting up to hold the temperature down, the people I've spoken to who specialize in this stuff say, look, it would probably slow the healing. There would be some impact, but it wouldn't start it expanding again, the ozone hole over the Antarctic. But it might, whereas we thought that we might be completely close the ozone hole by the 2040s, maybe you're thinking the 2060s. But it's not over any inhabited areas even now, so, you know, there's not even a lot of animals who are at risk from, you know, the solar radiation that the ozone hole doesn't stop. So I don't think it's a big issue. The other issue you hear a lot about SAI, about putting sulfur dioxide in the atmosphere, is that it moves the rainfall around, and there will always be aggrieved parties who lost their rainfall, so therefore you cannot do it because you're just creating opposition, and you know, people's rainfall is being cut and people are starving and so on. Actually, that problem was detected in the very early days by, you know, people doing mathematical studies. Nobody's putting stuff up in the air. It hasn't been done at all. But, you know, the usual way that they do the climate studies, which is mathematically, when they simulated in a model putting sulfur dioxide in significant volumes into the air, what they found was that it did move the intertropical convergence zone, which is basically about 500 miles north and south of the equator. Used to be called the doldrums in the sailing days. It would move that up or down depending on how much off of the band where the rainfall is now. I mean, the doldrums.
You mean expand the band or just move it?
Move it in latitude, so that, and this is particularly important for West Africa, because the West African monsoon is actually a monsoon which is part of that extending over land, the doldrums that we used to talk about in the Atlantic Ocean. Very overcast, very rainy area with almost no wind. That's what the doldrums were. And over land, it delivers a lot of rainfall, which is why there is a band called the Sahel in West Africa, which actually is in the middle of the Sahara, but gets rainfall from that band of weather. And it wouldn't disappear, but it would move south if you did a lot of geoengineering with solar SAI. Because basically, well, it gets complicated. We don't need to go too far into it, but if you do a lot of geoengineering, you're going to get a lot more rainfall. Okay, because, well, whether you do the geoengineering or not, you're going to get the rainfall because it's warmer, there's more evaporation. But if you put the sulfur dioxide up there, you will also move that band, which carries the rainfall with it, south. For reasons that the mathematics makes clear, but English language doesn't, so we just have to take that on faith. They found that if you put a lot of sulfur dioxide up there, you would move this band of rainfall, which includes several countries in West Africa and the Sahel, depending entirely on that rainfall for their agriculture. And suddenly the rain moves south and you're in the desert. Yeah, well, instead of falling up in Niger and southern Niger and Chad and that band of countries in the Sahel, it would fall on northern Ghana, northern Nigeria, which have enough rainfall already, and the people up north are now in open desert and starving. That was the image we were given already a bit dramatic, but plausible back then. So what did they do? They went back and they did their mathematics. The consensus is that no, if you actually set out to counter the full warming for the year, and you're loading all that sulfur dioxide into the atmosphere, you are going to move that band and kill off agriculture in several West African countries. And that's definitely not a nice thing to do. If you only counter half the warming, the amount of sulfur dioxide you're putting up there will cause the normal amount of rainfall in the normal places. So, no, you can't cancel all of the warming, but you can cancel half of it. Is canceling half of it good? Yes.
Yes, but can't you do half of that and then go do some other technology?
Exactly. Yeah, but that's the way you deal with that one, and that's the. I mean, in terms of the heavy lifting, that's the biggest thing you can do. Then you can start with things like marine cloud brightening. Marine cloud brightening, as opposed to the stratospheric stuff, is right down on the ocean surface in what they call the boundary layer. And you mustn't imagine people spraying stuff into the atmosphere to try to get it up into the clouds. You let convection do that. All you do is, with very specialized nozzles that will produce literally trillions of tiny bubbles of water a second, but you can get a trillion bubbles at that rate out of a bucket of water, onto the sea surface or just above the sea surface. Not very high push, tiny bubbles of water going through even tinier holes and being laid like a mat over the surface in the wake of the ship. And about half of that, particularly in the tropics, but it will happen anywhere, will then be lifted by convection, by, the warming of the sun, into an area, drying out and leaving only little morsels of salt from the salt water. The original water that's sprayed boosts the bubbles up, and as it boosts them up, the bubbles dry into particles of salt. And the particles of salt are lifted into low-lying cloud layers, and I've been in 3 navies, so I know about being at sea in the tropics, and I'll tell you, you're under this cloud almost all the time. It's a layer of, they call it marine stratocumulus cloud. A layer no more than 100 or 200 meters above sea level, so thin that you can usually see the sun through it. But if you thicken it up a little bit, you'll still be able to see the sun through it, but it will be reflecting much more sunlight, because clouds do reflect sunlight from their top surface. Okay, and so the marine cloud brightening, the other big number in terms of holding temperature down, is basically thickening up marine cloud to reflect more sunlight using vessels with little sprayers. They're satellite controlled and unmanned. You don't want 100 of these. They're the size of large yachts, not Russian.
We're going to put a photo of one on the back cover of Peace Magazine
Yeah.
because I interviewed Daniel Harrison, who's trying to save the Great Barrier Reef and he has a boat where you see the spray coming out the back. And
Yes.
so I'm going to put that on the back cover of the magazine.
Excellent.
Mm-hmm.
Okay, so anyway, there you have that. Um, by the way, while it works best in this low-lying layer of marine stratocumulus cloud, there's a Norwegian who did again the usual experiments on not in computers with data rather than actually going out in a boat. Um, but she concluded that, in fact, you could do it over any part of the ocean, including parts that don't have cloud. You'll get less cooling in areas that don't have cloud, but even the invisible moisture, because when the little morsels of salt reach cloud level, they turn back into little bubbles of water. They're the core around which water condenses into droplets. That's the whole point. Get the little bits of salt up there. I talked to one
Which,
of the
by the
people.
way, we should say it makes it whiter. That's the important thing.
Yeah,
The cloud becomes whiter.
the cloud becomes whiter. It reflects more sunlight, but in fact, the tiny bubble, drops of water that coalesce around the little salt particles that this process raises into the sky will themselves, without being part of a cloud, reflect sunlight too, so that you get something like 30 to 50% of the effect when there's no cloud around at all.
Okay.
And this has not been tried, none of this has been tried in open air because of this grim determination not to distract us from failing to do what we are, in fact, failing to do anyway. So um, there's this one, which is Stephen Salter was the guy he just died a couple of months ago. I saw him as recently as last year, and I hope the work he was doing is picked up by somebody because he started doing some very important
He's
work.
left money for them to continue. He has a workshop and everything. So
I know about the workshop. Yeah, there's former students of his who actually invited him to work in a building that they had bought. So the work will continue, but it definitely needs vastly more attention because it is.
well, the problem is, as he put it to me, the nozzle isn't good enough yet. They need to perfect that nozzle because it's very important. If you don't have the right kind of the right size of spray, it doesn't work, or it could even be harmful.
Yeah, that's right. But this is an engineering task, and Stephen Salter was an engineer. And actually, the reason how he got involved in this was that the guy whose idea it originally was phoned him up and said, "Can you make a nozzle?" He said, "Yes, of course I can." He still hadn't done it when he died, but he was definitely close, he thought.
Latham.
Anyway, the great virtue of that is that it is absolutely stoppable. If anything goes wrong, you just stop spraying.
Mm-hmm.
And all the side effects go away within a day if there are undesirable side effects, or if somebody downwind thinks that you caused them damage or whatever. So those are the marine cloud brightening and stratospheric aerosol injection. They're the two big tools. There will be others. I could tell you one other that.
Tell me. Because
There's-
I have about a dozen others, and I'll be interested in which one you think is
no.
number
This is
three.
okay. This is one that's basically one guy with an interesting idea. The problem that we really need this stuff for, we should be doing it in a sort of low key way right now, and cutting half the warming because we're already in the danger zone, and every temperature step up, the risk of something really bad happening goes up. The climate does not change smoothly. It changes in sudden lurches.
Mhm.
And we are close to causing some of those lurches, but we don't know exactly. We're not there. If it happens tomorrow, and it could, I know people who think it's happening right now. And we'll know about that by probably September, whether
Mm.
we are in the middle of that kind of lurch upwards right now. Some say yes, some say no. Most want to wait and see a bit more data, but it's frightening. We don't, none of those things, stratospheric aerosol injection, the marine cloud brightening, various other means that have been suggested, you couldn't get any of them up and running in 6 months. Most of them you couldn't get up and running in less than 6 years.
Mhm.
And that would be a crash program. Um, and so I ran across this fellow called Bob Nelson, who is a retired engineer with the Caltech group, the Jet Propulsion Lab, JPL,
Mhm.
who have done some extraordinary work over a period of about 40 or 50 years, and atmospheres on other planets and all that, which is what he used to do, and so on. And he showed up at the last but one of the semi-annual, every 2 years, conferences of geoengineers. And he was treated with disrespect, frankly. I didn't disrespect him, and I talked to him then and subsequently. This is a man who is a senior research scientist at the JPL for 40 years. Come on. He's not a nutcase.
Yeah.
And what the precise problem he wanted to address was, what if we suddenly needed to do this now without
With
any of
AI or what? Now.
an atmospheric intervention? Because
Okay.
we know you're going to have to build ships to do marine cloud brightening, and you're going to have
Mhm.
to design the nozzles. You're going to have to build aircraft to get up into the stratosphere to spray the sulfur dioxide. If you're going to do
Can't they do it with existing airplanes?
no, no.
Really?
Not really. 65,000 feet, and they tend to do altitudes still in feet. 65,000 feet is about the minimum at the equator to get the sulfur dioxide into the stratosphere. Spy planes fly that high. Enormous wings, spindly little bodies, very specialized engines because the air is very thin up there. Nobody has built a dump truck that could carry up sulfur dioxide to that altitude. It's not like it's technically impossible, it just hasn't been done. And airplanes do not appear out of nowhere. It's a development process and it takes time. I do know one scientist at the National Center for Atmospheric Study. That's the National Center for Atmospheric Research, NCAR, in Boulder, Colorado, the U.S. government.
Mhm.
She's a German scientist who uh, thought, well, maybe what you could do is use a plane that's able to get up to 50 or 55,000 feet. We got lots of them. Private jets tend to fly at that altitude to stay out of the way of airliners.
Mhm.
Um, but if we could then put the sulfur dioxide in little particles of something that warms in the sun, and would then, by warming, create an upward current that would carry the sulfur dioxide the last 10 or 15,000 feet into the stratosphere. We can't go there, but we could put things in there with a warming, basically soot particles that would warm up, rise, and carry the sulfur dioxide with it the last 10 or 15,000 feet. So there's one emergency measure, but even that would take some convince. I'm not sure that would work.
Mhm.
She's not sure that would work. But here's Bob Nelson's. Bob Nelson, his whole work was about working with reflectivity on planetary surfaces 40 years of that at
Painting
JPEL.
roads white?
Well, that sort of thing. But no, the painting roads white, first of all, if you ever driven on a road that's paved white, you need sunglasses in the dark. I mean, but beyond that, um, the the problem he had was existing technology, and we needed now. Okay, how would you deal with that? And he thought, well, actually, salt has about the same reflective, table salt has about the same reflective qualities as sulfur dioxide does. And all you're trying to do is bounce sunlight back into space, right? Sulfur dioxide does that, table salt does it. You can't put, say, table salt into the stratosphere because half of it is, in fact, chlorine, sodium chloride, right?
Mm-hmm.
And chlorine is precisely the element that eats up the ozone.
Yeah.
So you can't put it in the stratosphere. But he thought, well, salt you can put in the troposphere down here, the bit where we breathe. I mean, we put it on our food. It's not a dangerous substance. So he thought, well, if you needed it tomorrow week, and you needed to use existing technology, you could just get a bunch of 747 freighters and distribute table salt at about 30 or 40,000 feet, tiny particles of table salt, which in the interim would give you enough reflection to hold some temperature down. He got a bunch of people to do some studies on it, and he reckoned, 300 747, the freighter version, jumbos, about 4 times a year, spreading table salt into the atmosphere, would reflect enough to give you 1 degree of cooling. And, that's, I mean, who knows? But it's
Yeah.
nice to have something in your back pocket that might work. And his task, which, if anybody knows where to get the answer to this, because he hadn't managed to get through to the right people, the question is, can you make the salt particles small enough that they don't immediately fall out of the air? I mean, the size of the grains of table salt, well, table salt falls to the floor, right? So that's too heavy.
Grind it up. Why can't you grind it?
Yeah, I know, but I mean, yes, but it must retain its reflective possibilities. It's
So if you grind it too small, it might not reflect it.
might lose them, but that's what you need to test. But the point is that this isn't 7 years of testing; it's about 3 weeks, if you can get somebody to do it. The planes are there,
Yeah.
table salt is there. I don't know if this works. I said, tell
Okay,
you this.
let me top you, okay?
Okay.
There's somebody else, and I don't know anything about this. I dismiss this as implausible, but they say rice husks are white, and they float, and they will float on water indefinitely. And there's a hell of a lot of it, because when you polish all the rice in China and India and all these places, you got a lot of rice husks. So if you sprinkle that on the oceans, you could cover all the oceans with floating white things that right there would reflect a lot of the light, back into space. Okay? Game over. Okay. See if you can top that one.
I was expecting something else, because I know that the Center for Climate Repair in Cambridge and the Indian scientific body that does climate work cooperated in sprinkling rice husks in the Persian Gulf in an experiment. Yeah, this was Hugh Hunt and people like that last year. But unfortunately, then a huge storm came along and sank it all. So, but they were actually using the husks to carry sort of a smorgasbord, but of things that would encourage algae to bloom in large quantities. So, it's sort of, and the husk was just the little boat that they floated on. But if you get the algae coming along and starting to eat all this stuff, then you get the bloom and a huge amount of absorption of carbon dioxide, which may or may not sink to the bottom.
Right. Well, I noticed you haven't mentioned that the ocean. Usually it's iron they want to float. They're not float. I mean, they sprinkle tiny bits of iron filings, and
Yeah.
this in certain areas of the ocean, it's not just iron. Sometimes it's potassium, or some places it's different things that there's a shortage of. But if they don't have enough of certain things, and iron is the main one, to grow, then the phytoplankton don't grow. And if you sprinkle it, then you can replenish and bloom your phytoplankton. It has a lot of effects. It exudes stuff that's good for the clouds. It feeds their fish, and it captures CO2 and can sink to the bottom of the ocean and be sequestered. So sounds good. I mean, I'm up for examining it, but you didn't name
Well, I know I'm in
it.
favor of examining it, but it was very much in fashion 20 years ago, and a bunch of entrepreneurs made fairly large amounts of money encouraging investment in it, and then folded their tents and went away. And nobody was able to prove that a significant amount of carbon dioxide was being absorbed by these plankton booms and wasn't eaten by fish and didn't sink to the bottom.
But you wanted some of
Or
it.
did sink to the bottom.
The only one I know that actually did it was a guy named Russ George, and he was hired by the Haida Indians in BC to enrich their haul of salmon. And so he did. He worked, and the next year they had a bumper crop of salmon, but the Canadian government came along and said, you can't do that again. So he's not been allowed to do it. I don't quite know why, but they thought that sounds like geoengineering, and we don't like things like that.
I don't think that, because it wasn't geoengineering, it was encouraging more fish. I mean, his idea was actually, let's have more fish, and the plankton will be fish food, so we'll grow the plankton for that. He wasn't even attempting to measure whether the carbon dioxide was being absorbed and sequestered at the bottom. So it was interesting. Maybe that's a good way to encourage more fish, but it's not about climate. There
was a guy whose name I can't remember, who is a real scientist and who was doing.
There was real scientists talking about it, and there was entrepreneurs putting money into throwing iron filings off the sterns of ships in large quantities. And there were algal blooms, but there was almost no scientific work done. That's not really what most of them were there for. This was 20 years ago. Now, there is some reawakening interest in it, but the large questions remain. I mean, first of all, this is extreme intervention in the ocean. You are changing the character of the population of living things in the ocean because I'm assuming you're not just doing it once a year like plankton blooms. You're doing it a lot more. And so I'm sure the oceanographers and the fish population scientists would want a long, careful look at this before they encourage this to be done on a large scale continuously. But it might work. I'm not saying it won't. There's lots of things need to be looked at, but you got to get over the taboo, which is no longer formal, but it's still there, on looking into things that might allow us to hold the temperature down, bearing always in mind the purpose of doing this is to restore comfort in some parts of the world, and the possibility of working outdoors in the daytime in other parts of the world. I mean, you get down towards India and places like that, and more than half the population works outdoors, and they're getting 45 and 50 degree temperatures. I mean, holding that down would be a good idea on a food production level and on a human life protection level. But I think that the taboo is still blocking a lot of research. There's more happening, but people are still. I mean, you look, for example, at David Keith, who has been one of the most earliest and most active investigators about stratospheric aerosol injection. He had government permission for tests of the equipment with which they would eventually test small amounts of a non-fossil, a non-chlorine based or a sulfur dioxide based gas in the air, just to see how it, does it clump if you're moving at speed when it comes out of the airplane, all that sort of thing. And he was just using balloons with little propellers on them. Had government approval from the Swedish government. And then I know the name, but I'd get done for slander if I said it aloud. So a well-known, if a bit niche, environmental group went and told the Laplanders, the indigenous people in northern Sweden, that this would be done at an altitude where their gods live and would disrupt the stability of nature, possibly the entire universe. And so the Aboriginals, to whom people must live, said, no, we don't want this done. They had talked to Keith and those people who talked to the Aboriginals first, but the other lot got to them. So they complained to the Swedish government. It was all canceled. It was all shut down. And so not long after that, Harvard University, which is where Keith was working, started moving to close down his whole geoengineering enterprise there. We had about 10 people working there on it. I think, and I don't know, I know David, but I haven't asked him this question. But I think that's one of the main reasons he's just moved to the University of Chicago. It's easy to persuade Harvard professors as it is Laplanders.
I hate to agree with you. I can't disagree with you, though. It's discouraging. Because in fact, there is evidence that the more people know about geoengineering, the more favorable they are, at least to investigating it, if not deploying it. And of course, it's so many different things anyway that it's not, you don't deploy it, you check out a whole bunch of different things that can be called geoengineering. And that's what we should be doing, all of them. Even the crazy ones. I'm in favor of
Testing.
the guy with the salt and the people with the rice husks and everything you want to check out. Let's do it.
Yeah, well, given
something will work, and we need it.
Yeah, exactly.
Yeah. Okay. Well, I hope your book does what I hope it's going to do, and believe it's going to do. I think you're going to make a big splash, and I've only had time to read 1/10 of it so far, but I've been totally wowed by it. All right. Wonderful to talk to you, Gwen. I think I should let you go to the airport now.
So far, yes. Thank you very much.
All right. It's been wonderful. And bless you. Project Save the World produces these forums. This is episode 594. Watch them or listen to them as audio podcasts on our website, tosavetheworld.ca. People share information there about 6 global issues, and we welcome your comments too. To find a particular talk show, check the scroll list on the homepage or use the search bar. Project Save the World also produces a quarterly online publication, Peace Magazine, which now serves as a free of charge newsletter to help mobilize knowledge about 6 global threats to humankind. We gladly email the magazine as a PDF or link to any interested organization in the world that works to prevent a global catastrophe involving war and weapons, global warming, famine, pandemics, radioactive contamination, or cyber risks. Just email us at office@peacemagazine.org and we'll add your group's email address without charge to our list. Please type "Subscribe my group" as the subject of your email. For individual subscriptions at $20 Canadian per year, go to pressreader.com on your browser and search for Peace Magazine.